Whoa. Sorry. Right. The two types of binomial distribution in your pure, both of which formulae are given on the formula sheet. Type 1 is where you have a positive whole number for n, and you would use this formula. The n1 that looks like a vector means n choose 1. So quick example of how you would substitute that in. So you would notice the key things are you raise the whole term to the power, and you make sure that in each term, so in each different term you've got here, the powers add to 5. So you can see you've got 4 and 1, 3 and 2, and so on. You then simplify them. So that's what that expansion would look like. You then have type 2, where n is a negative number or a fraction. So this would be the formula given. Now, because this is an infinite expansion, it comes from your sum to infinity of a geometric sequence, then you have a condition of validity. So x has to be quite small. So we say the modulus of x lies between 1 and negative 1. Right, example 1. So example 1, you've got a straightforward expansion where n is a whole number. Now they're asking for the coefficient of the x to the power 5 term. You're going to use your type 1 formula. So you know that if you want x to be to the power 5, you take the x term, make it all to the power 5. You take your other term, so that's going to have to be to the power of 3. And it doesn't matter whether you take 8 choose 3 or 8 choose 5. It's this symmetrical, the binomial coefficients, Pascal's triangle, they're both 56. So when you work that out, you get 48,384. Right, question 2. Find the first 4 terms of this expansion. Right, it's got a negative value of n, which means you use your type 2 binomial expansion. Right, however, what's great about it is it has a 1 exactly where you need the 1, so you don't have to adjust it. So you substitute into your formula. Remember, this is going to go on forever, this expansion, and then you work it out. And then you take the x bit that you are binomialing and you work out your condition of validity. So if the modulus of 4x is less than 1, then the modulus of x is less than a quarter, or x lies between a quarter and minus a quarter. Okay, right, example 3. So what you're going to now do here is find the first 3 terms of this expansion. So again, it's a negative power of n. So you are going to type 2, and that's the formula you are going to use. However, you need a 1 in that bracket, and you have a 2. So you're going to take out a factor of 2, but remember, it can't come out of that bracket that's to the power of minus 2 unless the 2 is to the power of minus 2. So you can see what I've done here using the laws of indices. So I'm going to so I take out a factor of 2 to the minus 2, which of course is a quarter, and I'm now going to expand my 1 plus x over 2 to the minus 2. So I substitute it in the formula, that's what I get, multiply everything by a quarter. Now remember, your condition of validity, you use the bit that you binomialed, so the modulus of x over 2 is less than 1. So x lies between 2 and negative 2. Right, final example, much more complicated. So it comes from partial fractions. So part A, they're asking you to write this expression in terms of partial fractions. Have a quick look. I'll go through this quite quickly because this isn't really what we're doing. The order of the denominator is 3. The order of the numerator is 2. So you don't need to do polynomial division because the order of the numerator is less than the denominator. Okay, it's got a repeated factor in those denominators though, so you set it up as you've learnt. You then do your thing, you do your partial fractions thing. Again, you don't really need me to do that for you here, so I'll just give you a little look about the work that I did. And then you finally end up with these neatly expressed in terms of partial fractions. Now, part B of this question is going to ask you to expand that left-hand side. So, hence, Find, i.e. using what you've just done, find the first three terms of the expansion of this expression. So you take your partial fractions and you write them using powers. You're going to have to be super organised here and do each one separately. So take that first one. It's got a negative power of n. So you use your type 2 formula for n being a negative power. So take out a factor of 2, but it's 2 to the minus 1. And then expand it binomially. Okay? Remember, to work out your condition of validity, you take the x bit you are binomialing. So if the modulus of x over 2 is less than 1, x lies between 2 and negative 2. Take the next bit. Okay? Again, n is negative, so you're going to use type 2, but you've got a 1 exactly where you want it, so that one's a bit more straightforward. Again, that's valid for the modulus of x being less than 1. Your next bit, again, almost exactly the same as the previous one, other than the power is different, power of n. So there's your expansion. And you're now going to put them all together, and just remember, you are taking away the last bit. So as you can see, I think when I first did this, I'd gone onto a different bit of paper and I put an add in. So don't forget, you are taking away that last bit. So put them together. You're only going for the first three terms, so the constant, the x and the x squared. Multiply out that minus bracket at the end, and then you are going to gather your terms together. So I think when you gather your terms together, that's what you're going to get. I've got 3 over 2 minus 7/4 x minus 13/8 x squared, and of course it goes on forever. Now your condition of validity, so this is an important thing to talk about. Your first expansion said x lay between 2 and negative 2, and your subsequent two say x lay between 1 and negative 1. You always take your narrowest one. If you took x lying between 2 and negative 2, your second two expansions aren't valid for that. Your narrowest of your two conditions of validity is the last one. So what you would do is say the expansion that you've just worked out is valid for x lying between 1 and negative 1, or the modulus of x is less than 1.